Okay, this will be a short lecture on valence bond theory. If you remember from chapter 10, 1170, we try to find the hybrid orbitals for the central atom of different molecules. So we had sp, sp2, sp3, sp3d, sp3d2. For valence, for the hybrid orbitals for metals that are part of a complex ion, it's a little trickier. Same basic idea though. So we have chromium here. They want to know the hybrid orbital for chromium in here, so in this complex. So we need to know the charge on the chromium. It's +3, we can see that. Here's chromium, but chromium +3, we're going to get rid of this. And remember, this is that exception, so that's why we don't have 2 electrons here. So we get rid of 1, 2, 3. So just to make sure that you got rid of them. Now, we need 6 empty orbitals, because each water molecule is going to come in with a lone pair. Each ligand will. So the ligand comes in with the 2 electrons, so what the central atom has to have is an empty orbital. So we need 6 empty orbitals. Now these ones I've scratched out, those are empty, so we can't touch these, even though they're half-filled, and that's what we were looking for back in chapter 10. Now we need completely empty orbitals to allow the 2 electrons from the ligand to attach. So we start here, 1, 2, 3, 4, 5, 6. So this would be D2, S, P3, because we're going order. There's 2 Ds, 1 S, 3 Ps. Let me rewrite that. So D2, S, P3. Those are the hybrid orbitals. Now when they hybridize, they turn into 6 that are exactly the same kind of shape, though they go off in 6 different directions, and this is the hybrid. Or the hybridization is D2sp3. So what you do is you find the central atom, you write out the orbital diagram, and you can use the noble gas abbreviation. You write it out with the full electrons, then you take away the electrons. The s electrons go first. That's always the case. We learned that back in Chapter 9, actually, for the transition metals, we remove the 4s electrons first. And so let's do it again down here. We have iron. It's in, now the cyanide has a -1. There's 6 of them, so -6, so this must be +3 again. Here's the orbital diagram for iron. So since we got to get rid of 3 of electrons, we get rid of these 2. And sorry, I can't erase them, but just know that that's now empty. And then we got to get rid of a 3rd, and we get rid of the one that's paired up. So now we can't touch any of these. So we have to use this one, these next 3, and then we go into the 4Ds. So that's why I didn't draw the 4Ds up here, because I didn't need to. We had 6. But here we needed them, so now this is sp3d2. That should be very familiar. And we know that sp3d2s, like for sf6, a molecule that we'd see back in chapter 10, created an octahedral structure, and that's what we have here for each of these. This one just turns out doesn't have the right orbitals to do something that we're familiar with, but you just fill in it. So if this one was missing, we would have started here. This would have been D, S, P, P3, D. So they can get a little wild looking, but just follow that procedure. Write out the orbital diagram, remove the electrons starting with the 4s. The guys that I give you, these, now this is +3, the metals that I give you will be from that first row. So you'll be able to use this orbital diagram straight out. You just have to put in the different number of electrons and take away the number. It doesn't have to be +3, they just happen to be here. It could be +2, +1, +4. So just make sure you remove the right number of electrons and then go from there.